I thought when I saw this ln of stuff in there, I thought I was going to have to start with something from my purple memorized sheet, but they were nice on this one. They gave us what the Maclaurin series was for the ln of 1 plus x. And then what we see down here is ln of 1 plus x over 3. So that means all I have to do is simply take the x over 3, plug it in for those x's right there. And then once I get a few terms with the general term, then I could take the x and distribute it, multiply it by those few terms. So let's do that in part A. Let's do one step at a time here. So again, they gave us the ln of 1 plus x, is all of that, including that general term. They gave us all of that. And then when I just do the ln of 1 plus x over 3, you just take an x over 3, plug it in for all of those x's right there. And I can do that as well with that general term. So that becomes an x over 3. This is x over 3 squared over 2. So that's x squared over 3 squared. That 2 carries down. This is x over 3 cubed over 3. So that's x cubed over 3 cubed. And then that 3 carries down. And then I advise you to just kind of leave them alone like that. If you did have to notice a pattern on any of these, it might help to leave it alone like that, because if you multiply stuff out too soon, then you might not see what you need to see there. But I can actually get this general term without noticing a pattern. So, I mean, you can multiply that out, but usually I hold off on that because you could always multiply that out and, you know, and at the end of that problem if you had to, but you're allowed to kind of leave it like that. Now, when I was doing this, plugging in the x over 3, I was also trying to get the general term here. So ignore this part. Just look at this part here. To get the general term for this, I just replaced that x right there with an x over 3. So that became x over 3 to the n over n. And I already know that -1 to the n plus 1 is going to carry down. But see, now with this x in front, to get this f of x, I just got to take now and times that stuff by the x. So I'll take the x and I'll distribute it. And that becomes an x squared. I go x cubed, x to the 4th, x to the 5th. And now if I take this general term that we said here, and I times that by an x to the 1st, I guess technically those aren't the same bases, but you know, we could rewrite this as 1/3 to the n times x to the n, right? And if I have x to the n times x to the 1st, I can add those exponents up, get x to the n plus 1, the 3 to the n is on the bottom, that n is on the bottom, and that is your general term for that expression that they requested there for the f of x there. So I got the first 4 terms there, and I have that general term. All right, and then part B, it says find the integral of convergence, which means you're going to do that ratio test there. So here it says for f, and this is your f, is that new general thing that you just figured out right there. So I'm going to do the ratio test with that. So I'll do a limit as n approaches infinity. Got the absolute value bars in there, so it's going to make it all positive, but you're replacing those n's with n plus 1s, and then you're dividing by the original, which means you're multiplying by the reciprocal, and do your simplifying like we used to doing with the ratio test, right? Make that x to the n times x to the 2nd. Those will cancel out. Same thing with the 3's. You see how to do that. You guys are good at that. And then you can pull out any of the non-n terms. And then you can leave that 3 in there, or you can pull it out. I'm just going to pull it out this time. This limit is equal to 1, so then you get the absolute value of x over 3 is less than 1. If they ask for like a radius of convergence, I can multiply both sides by 3 and I'll get the absolute value of x is less than 3. That would have been my radius of convergence. But since they said integral convergence, then you got to do your less than sandwich, and you'll get that's in between -3 and a +3 without the bars. But then anytime you get an interval like that, you need to check the endpoint. So we got to take x equals -3 and +3, plug it in for this x right here. So that carries down, and I have -3 to the n plus 1. And then that carries down. And then remember what I showed you in the BCX video lectures, you can rewrite this as -1 to the n plus 1 times 3 to the n plus 1. As long as you keep those the same, you're allowed to do that. And then the 3 to the n plus 1 and all that stuff carries down. But then here you have -1 to the n plus 1, -1 to the n plus 1. Those are the same base. You can add those exponents up. That becomes -1 to the 2n plus 2. Now we know 2n is always an even, and if you're going to add 2 to it, if you take an even number and add 2 to it, then 2, you're going to get an even number, which means that's always positive, which means you just have this, and then you could rewrite that as 3 to the n times 3 to the 1st and get some things to cancel there. Then you're just going to get 3 over n, which is a divergent p series. And when you plug in x equals 3 to that guy, then you could just cross some stuff out right away, but then that's an alternating series. That's a converge alternating series. You can do that alternating series as in here. So since the -3 diverges, keep that a parentheses. Since the 3 converges, make that a bracket. So you got to check your endpoints on there. And then the last part, it says this is a 4th degree Taylor polynomial, and it says alternating series error bound. That just means we're going to use the next term in our pattern there. And And this is, again, if you plug the 2 into your Taylor polynomial, you're going to get an approximate answer on the Taylor polynomial. If you plug in 2 to the original function, then you'll get like the exact answer. So this is just the difference between the estimated answer and the exact answer. When you see alternating series error bound, we're not talking to Lagrange or anything like that. That's just the next term. And then so if they said you use a 4th degree, that means they went up to x to the 4th. And so what you got to do is go to that next one in the pattern, that 5th degree one. So that's why I chose that one. And you're just going to do the absolute value of that. And it said about x at x equals 2. So you're just going to take that x equals 2, plug that in right there. Now, if you do get stuck with some larger numbers, you could kind of, just leave it like that. All right, you'll be good there. But if you can just simplify that a little bit, then go ahead and do so. But they do say, like, if you have a crazier fraction, you have trouble simplifying, you could just leave that alone. If you mess it up, then you might lose a point or something like that. But yeah, pretty good problem. And then we still should know that memorized sheet in case we need to. But it was nice of them to not worry about that on this one. Hiking trails.